This meeting is being recorded.
All right. Welcome everybody to this new SIG meeting. As you know, you're being recorded and you're subject to our contributor guidelines for these meetings. Actually, there are a few topics, but I want to start with announcements because they should be quick, and then we can have time for the rest of the topics. So first of all, let me actually share my screen. Do I have the permission already? Yes, right? Okay, so can people see my screen?
Yeah, I can see your screen.
Okay. First of all, we have the annual report up. It's almost, we already received a lot of comments, and we actually, or Abdullah and Agway started open some issues from that. For example, people were asking for an APAC friendly time for meeting, and the current proposal is there in the issue. And such meeting is planned to be monthly, and of course, if there is no agenda, we would cancel it. But and the other thing is that there is a doodle to set up a time that works for most people. Of course, this likely wouldn't work for people in Europe and people in the East Coast of North America, but that's what we have to give up. And last, we have added a new sub-project. This is in the context of the batch working group that is starting, and we published a new repo for queue, which has the objective of implementing job queuing. You might have seen the design docs and API docs. So feel free to collaborate, and once the working group batch meeting is set up, there are things we can discuss there too. But otherwise, we can already discuss through issues and whatnot. So that's all the announcements I have. Does anyone have any questions?
Just one more thing about the monthly meeting dedicated for the APAC time zone. So basically, because that is dedicated for APAC time zone, I like that time to be stick to the Asia time zone. That means if you are in a daylight saving area, you might change your time a little bit. Yeah, I just want the time to set for them.
And I guess since all the chairs and TLs are in North America, I guess there's, I mean, we have to do it early, right? Yeah, early for that time zone, probably. Okay.
So could you, are you going to post a new time on the web page, on the SIG page?
Can you, so there is a doodle now. Can you vote on the doodle? I think there are a lot of options there. Oh, actually, where you only added one day, like.
Yeah, just ignore that specific day, and I think we will still host it on Thursday. But if it's an issue, we can discuss. But just let's temporarily fix the time to Thursday, and the slot. There's a lot of options there you can choose.
Yeah.
But
but again,
that one is for the APAC. members, so I don't think a lot of APAC members joined today's meeting.
That's true.
So we will keep this meeting, right, for the US?
Yeah, exactly. Yeah.
Okay.
Yes.
Okay, sounds good.
Yeah, the bi-weekly meetings will be kept. It's just additional monthly meeting.
Okay, sounds good. Thank you.
Okay. With that, we can have Denisio Tokashi. Is Denisio here?
Yeah, hello. Can you hear me?
Yes.
Yeah, brilliant.
Wait, can you give permissions to Denisio?
Yeah, could you try to share your screen? If not, I will try to give you.
Okay,
host.
let me try just a second there. Okay.
Yeah, give it a try.
Okay, can you see then?
Yeah, cool. We can see your screen.
Okay. Okay. All right. Well, first of all, thank you guys for having me here and giving me an opportunity to show on the products on the Intel and yeah, and today I'm going to showcase a little bit on the telemetry-wise scheduling and see what way we are up to there. So the current desires for the talk about the scheduling is that we would like to have a kind of a mechanism that expose show the node properties such as temperature and workloads and under such way that can indicate problematic nodes and that try to avoid scheduling. And if we have that kind of mechanism and identify those problematic nodes, and if we also have pods already running on that, try to migrate it to a more suitable nodes, and at the same time, if possible, to give a support to any of the external components to relate to all those problematic nodes. So telemetry-based scheduling functionality is using actually the telemetry data that is available from the work nodes. So in addition to policy that is written in such a way that can take in consideration those metrics and the current state. Then based on the rules that the policy and have those strategies relate on those rules. If those rules are broken, such kind of event relate to the strategy occur, and again, based on the metric that they've been reading from the work nodes. And with that, have a kind of response to help the scheduler to take the best options and decide what the best nodes where the pods can be scheduled. So at the moment, we have under telemetry-wise schedule policy 4 strategies. Down schedule, that is a multi-rule strategy where the nodes that broken these rules are put out from the node list that is returned to the scheduler. So scheduler metric in this case is just a single rule and is used just to rank or the list of the nodes that are suitable for scheduling and related with the metric that is described in the policy. The scheduling and the labeling, they are very similar to each other. So they are based on, again, on the rules described on the policy. And if those rules are broken, the node receive a label, and these labels used either for the scheduler to schedule the pods that run on that, or used by the scheduler to avoid scheduling the pods on those nodes. The main difference between on the labeling that is a new strategy just we added recently is give more flexibility, because the user can customize the labels and can in that way, based again on the metrics, can transport or can add the information to the nodes. So that a quick overview of how the metrics works and through and the telemetry collect those metrics to do the business. So we have to have on the cluster the custom metric pipeline up running, and where it is composed by the metric exporter for each one of the worker nodes. Those metric exporter going to expose metrics, tons of the metrics related to the work node, and then be collected by the Prometheus later on as a time database. They're going to collect in real time and store those data and be transferred to the custom metric with the help of the Prometheus adapter. Once that the custom metric APIs have those metrics is ready to be read by the telemetry or scheduling, and together the policy that is the user have created, link it to the application to be deployed, going to decide what type of the rules are broken or not, and based on that, going to return the node with the list, those nodes that have they are suitable for the to be scheduled. In case if we have one of the strategies regard, in this case, schedule metric, we're going to also return on a list on the priority order. And with that list, after request for the schedule is going to do the best decision and deploy the application on the best nodes and avoid those problematic ones. A quick overview of what the demo I'm going to show is we have a cluster of the 3 work nodes there. So after and then of course the custom metric pipeline up running. So after deployment or the telemetry scheduling application, the policy immediately start to analyze those policies and the metrics and verify which one of the nodes are breaking any rules through the policy, defined on the policy. In this example here, sorry, it's just a point here. So the work 3 are breaking one of the rules, and then they are read out of the nodes that will be receiving the workloads. So once that if we have a priority list, we can see that we're going to return to the scheduler, and the best node will be chosen for allocate and schedule the pods on it. In this case, on the work 2. So the pods now that are happy off and working 2, and but everybody knows that's not always the case. So the metric start to fluctuate, and then get to reach it a certain value that crosses the threshold, and this threshold that related on that case breaks our rules on the labeling strategy in this example, and the telemetry schedulers mark this node by adding the label, a customized label, and say, okay, this node cannot receive any more pods than that. But then what happened with those that are read up and running, so that's we need to have the help of the Kubernetes scheduler, which is going to verify that this node has is being labeled a problematic one, so and going to evict those pods, and later on together with telemetry scheduler, scheduler going to reschedule those pods and most suitable nodes. In this case, the only one left was the worker node. So the pods again happy, and the metric value for the worker 2 eventually reach on the level that is not breaking the rules anymore, and telemetry scheduler looking for that and remove the labels, and the worker 2 is back again to be available for scheduling. This is an example of the scheduling policy. So here on the 3 strategies, as I mentioned, they don't schedule that work like the filter. So the metric here in this example, the health metric, just an indicator that the nodes are optimal for receiving pods or not. So if it's equal 1, that means that the rules are broken here. So that please don't schedule on this node. Basically, that's the saying. So telemetry aware scheduler go through all the nodes and make the selection of those that are available that doesn't break this rule. For those that pass, they're going to check now the scheduler metric strategy based on this metric. In case here's the temperature, and they're going to prioritize those that have the lowest temperatures. So they're going to be scored highest for those that have the lowest temperature. And this list of the available nodes are going to be sent to the schedule, and the scheduler is going to schedule the pods accordingly to this priority list for those pods that have a link to this policy. The third strategy, the labeling. So again, it's a rule-based strategy with the specific metrics here, and memory used in card 0 and memory used card 1, and if it's greater than 100, break the rules, and then telemetry aware scheduler going to add this label on the nodes that break this rule, and the same for the second one. Quickly show the scheduled policy here, and it's a simple one. They just remove pods that violate the node affinity. So, and this is an example of the application, a Nginx application of 5 replicas, and the two most important part here on this related to the telemetry aware scheduler is the link to the policy here, and this section that is related to the affinity rules, where define the pods that communicate with the scheduler, and this scheduler showing that if the nodes have those labels on it, avoid scheduling there. So no pods on this the primary file are going to be scheduling on those nodes, and this scheduler, if you have those labels on that, if there are any on pods on this the primary file on the node. So I'm going now to show.
Sorry, I don't know if I want to leave time for the next presenter. So, and I think I got a good understanding with the presentation already. So I already have some questions. So let me start. I think a general design question that you should do, you should make yourselves, is whether whether what you're building can be achieved by extending Kubernetes rather than replacing a component. And in this case, I think the question would be, can we reuse, you're already reusing node selectors, but can we reuse, for example, node tains? So let's say your controller, instead of feeding the scheduler, it would just add or remove taints based on the condition of the node. And then the pods can use a regular API. The APIs already exist to control whether they want to be scheduled when there is high temperature, or whenever there is certain metric or certain situation in the node. So has this? Have you thought about this? Have you thought of just setting taints labels based on these metrics?
The taints. So the labeling strategy actually added the labels, and that those labels work. You can say that work like that taints. So and try to avoid the pods and that. I'm not sure if that answers your question.
Yes, partially. So the advantage of taints is that it would affect every pod without them having to have a selector towards it. So that's if I were to think about this myself, that's where I would start. And then when we have exhausted all the options, then we can start thinking about the scheduler, about adding a scheduler plugin. So that would be my general question. But what are you looking for here, are you looking for contributors? Are you planning to present to? Do you want this to be merged into the Scheduler plugins repository or into main Kubernetes? What is your ask?
Well, it's the first one is just to show what we are working with, and we asking for contributions on the project. So yeah, so it exposes more the project itself. The idea is add more features and eventually improve it and go to the plugin direction as well. So it's just showed exactly what we are doing at the moment.
Okay, great. I hope my questions help you with your future designs. Does anybody else have any questions?
I'll do just as a little bit of added information. This is, of course, a very simplified example, but there are cases that we are addressing where pods are looking for particular node characteristics as far as where the metrics are. And that's the use case for this. So it's instead of doing a taint of your full node, right? It instead lets you do something specific for the types of workloads you're running.
Okay, so maybe that actually links with what Patrick is working on. I don't know if I thought you were from the same company, but I'm not sure. But Patrick is working with on something related, so maybe this could be merged in some kind of way. Maybe I'm speaking too soon. Any other questions or any other thoughts before Patrick has the chance? Okay. Thank you. We have a few minutes left, so I want to give Patrick some time to ask his questions.
Okay, thanks. So I basically want to gather opinions about some design choices that I currently have to make. So I started working on a CAP called Dynamic Resource Allocation. It's supposed to be a replacement or an alternative to allocating resources that are provided by third-party cluster add-ons, the device driver, something like that, where the current device manager API is not flexible enough. And the design at the moment is in a pending CAP, where based on my experience in the past from CSI with implementing a scheduler extender, I was now trying something else. And my current approach is to share information between the scheduler and a cluster add-on through the API server. The main motivation is that both the scheduler and a resource driver running in a pod automatically have the necessary configuration to talk to the API server. They get authenticated. All of that is handled, and it's portable across Kubernetes installations. The concern from reviewers like Aldo was that this will put additional load on the API server. And that's true. That's a valid concern. I'm now trying to figure out whether there are alternatives. And one prior art example would be scheduler extenders, where the kube scheduler gets configured to call out to some webhook and pass information to that and get information back each time it basically runs certain operations or checks. And I was really just trying to, or wanted to reach out to you guys and ask whether that is something that has been successful in the past, because from someone who has tried to use it and has tried to explain to users how they can configure a cluster to use something like a scheduler extender, it seemed to have quite a few drawbacks. And I know that, for example, that in Red Hat OpenShift, support for scheduler extenders is getting removed. You can't reconfigure the scheduler anymore so that it calls a custom webhook that you as a cluster admin added to your cluster. And I'm afraid that if I try something similar with dynamic resource allocation, it will be it will be a complete showstopper for some cluster admins. But I really wanted to ask you guys and get some opinions.
Yeah, I can comment a little bit on the two questions. So regarding the first question, that whether it's a good way to have the information necessary in the API server so that it's available to both the scheduler and the node component. I think this is the correct way. And Aldo mentioned that there may be some additional overhead. I agree, but that is the Kubernetes philosophy, to not share information between two components other than API server. So I think one way to improve the overhead concern is that we only communicate with the minimal information. If you look at think of the node resource sharing with the scheduler, is that the scheduler only look at the node's capacity. It doesn't look at any, like how many resources it used over time, right? Schedule doesn't look at that. And also node doesn't provide that. So I think that's a good design, because we only need to look at the initial value of the node, unless the node get like several CPUs added to over time. So basically, scheduler should calculate the resource usage in a specific node with the initial node capacity value. I think that rule can apply to any other resource, like resource-aware plugin, stuff like that.
Yeah.
Yeah, and this is the first question. Yeah, go ahead.
So you are arguing basically that the scheduler needs to know what the semantic of a resource is. That has been tried before. There has been an attempt, I don't know, 1 or 2 years ago, and you would need to look up the Google Doc to describe additional resource categories in sufficient detail to implement something like that. And I think that effort stalled completely, because it's very hard to have a thorough description that is descriptive enough to actually cover real world use cases. And the other problem is, even if we come up with something for the use cases that we know about now, if some new hardware comes along with additional restrictions that can't be described with whatever metadata we defined before, we end up with updating the core Kubernetes components again and again. And that's why I think that this approach will not work for anything that is more complex than something that can be counted. And that's the current device manager API. That's the problem why I'm trying something else. The current design explicitly tries to keep all logic out of a scheduler. It just asks for, or it knows that a resource needs to be allocated, and it leaves the handling of resource parameters, constraints entirely to the cluster add-ons. But that implies that there must be some more communication between the scheduler and the add-on, because if we look at something like volume provisioning with delayed allocation, there has to be some communication from the scheduler to the CSI driver in that case, or the provisioner, that this is a node that the kube scheduler currently thinks is suitable. And something like that will be needed for the generic resources too, except that we basically need to communicate a lot more than just one node. We need to have information about what could be the suitable nodes that are suitable according to what the kube scheduler knows, and then the resource driver needs to respond with his view of which nodes could be used or could not be used. Whether we make it a positive or negative statement is a bit open, but this information is what needs to be passed back and forth, potentially multiple times, because the kube scheduler might look at the current situation, might identify some suitable nodes that fit the port for RAM, CPU, and so on. And when it asks for resource driver looks at it and sees that some nodes are suitable, then, but that by the time that the information goes back to the scheduler, the situation might have changed again. That's why this current proposal has quite a bit of, or plans to have some back and forth through the API server with that information. And that's the crucial part where, yeah, we could decide to short or to avoid the API server and for this kind of information, but then we are back to the webhook design and how to configure that.
Sorry, yeah, to clarify, my concern is precisely not like overwhelming the API server, is rather overwhelming the kube scheduler with this back and forth. Basically, there is no clear decision. It's very hard for it to take the final decision, and there could be a lot of, well, retries and whatnot. So I think that's the major concern with the proposal.
Okay.
Now there is, yeah, I agree that webhooks are problematic. Although I don't know how problematic it is to leave this to the providers. For example, I know you're coming from a hardware perspective, but let's say I'm trying to reconcile with my cloud provider hat. So if, let's say, I'm deploying your hardware in Google Cloud, I would likely install this webhook. If we go this path, I would install this webhook on my clusters in behalf of the users, so that users don't have to do this installation, because I'm already providing the hardware, right? So I should provide the support for it. So that's the way I'm seeing it, and that's why I think webhooks might be possible. And I think the same could be applied for other providers. Now, I guess the complication is when you have someone installing it by themselves on-prem, right?
Yeah,
Is that
that's exactly the problem. I understand for the cloud providers, you probably have a team that are capable of doing this, but for many of these things, we are talking about private installation, because it is dedicated hardware that might not be available yet in the cloud, and still people want to use it. And then they are facing this installation challenge. And when I think about the OpenShift model, where they get support from Red Hat for running OpenShift locally, there's just no way how OpenShift or the Red Hat folks, for example, could then make sure that certain cluster add-ons work if they depend on reconfiguring the scheduler.
I see.
So yeah, that is the main problem. And it gets even worse if you think about situations where you have two different cluster add-ons from different hardware vendors, say something for the compute node, and then some PCI card that you plug in. If we think about other alternatives like building your own scheduler, that just doesn't work in this scenario, because who would build a scheduler for the hardware? Is it the node, the main board manufacturer, or is it the PCI plugin vendor, a PCI card vendor? We need a way how to compose things in such scenarios.
Mm-hmm. So I guess the other approach would be giving away something, giving away some expressiveness, some like generality, so that we can reduce this back and forth. I don't know if it's possible.
That's exactly, yeah, I think that's not possible. It's exactly the same thing. You basically define some generic hardware description, and then implement probably fairly complex code to handle different edge cases with that definition, without even knowing whether all of these edge cases occur in practice. But you try to be a fairly generic. If you are not generic, you're designing something that is too limited. And if you make it very, very flexible, you write complicated code, that you can't really properly test because the hardware doesn't exist yet. So I think that's a losing proposition. I don't think this is viable.
I think I can talk from Red Hat's perspective. Like we recently had a customer who is almost in the same or similar situation where they want some of the resources to be exposed on the node, along with scheduler making call of most of the resources that are Kubernetes native. But there are some additional resources that they want either scheduler plugin or extender or some other mechanism to be available for the additional resources. And I think we had faced similar set of questions like what would happen if there are other resources provided by other companies where this may actually conflict. And to be fair, I think these are the same set of questions that we are thinking about too. At this point of time, some of the things that we have suggested is go ahead with the scheduler extender. And one of the things that we wanted to bring up during this call, or perhaps in the later calls, is what is going to be the state of the extender? Like as of now, it's simple HTTP or HTTPS. We would like to have gRPC or some other mechanism to be available. So I'm slightly sidetracking the issue, but I think to answer your question, I think we are fine with scheduler extenders from Red Hat.
Yeah, scheduler extender wasn't supposed to achieve the thing you want, but it's if you do it that way, it sounds like a hack because extender was supposed to invoke in different phase of scheduling cycle, and it has some specific format and function signature that you communicate with, and that is not generally used for you to grab additional information to facilitate your scheduling, right? So if you guys want that kind of interface, I think we should start from scratch to design that. It's like in the beginning of the scheduling cycle, you call a webhook and get the information you want and hardwire that to the snapshot of the scheduling snapshot. Sorry, the snapshot in the beginning of the scheduling cycle. And I think that is way better than using the current extender to hack to achieve what you want.
Well, the current extenders could also be extended, right? It's not the API could evolve still.
Yeah,
that's a possibility too. But I guess my general question in regards to the CAP is, can we explore all these options? I think some of them are explored, but for example, this extender or adding a new API specifically for hardware, for devices, what will we lose? What are we gaining? What can be simplified? Things like that. I think that's missing, and we need to have that discussion because ultimately, it's not just SIG scaling needs to approve, right?
Yeah.
The architecture as well.
Yeah.
For such a massive change, and we need to be careful.
My preference is that if we can make things simpler, then we should do that way. So let me ask another question: is that what's the single source of truth to make both the scheduling and the runtime placement decision in terms of the resources? So if we can abstract that kind of single source of truth, either it's a CRD or either it's a finalized spec to the pod, then that we can have a whole picture on what the single source of truth is, then the things will be simpler. That scheduling can rely on, and also the node component can rely on, and also reconcile on the state. I think that would be a simpler solution to achieve.
Well, in the current proposal, that is the allocated resource. that is something that must have been prepared and put aside on a node, or if it's local to a node, so that a pod that runs on the node and uses that resource really can start. That's the current approach with the cap that as it exists now.
So we are running out of time. I think what I would like to have is to have another presentation of you, but maybe we can do it in the working group batch. Now we will have a lot of Node folks there. Although Swati is here, so maybe she already has some thoughts. Anyways, that will be 1 hour. Maybe we'll have more time to discuss there. We have time, right? In a sense, we have time because this didn't make it to this release.
Yeah.
So
well, I'm trying. Right now. I'm basically trying to figure out whether I need to redesign something or whether I should do the prototyping as we kind of agreed out of tree. And the prototyping would be based on the current cap to get a better feeling for performance overhead. How does it work in practice before trying something else? If we need to try out different alternatives, I just need to start somewhere, and I might as well just start with the current cap.
That's possible, yes. If you can present this prototype, and maybe we will have to have an ad hoc meeting with architecture folks.
Well, I still need to implement it, of course, but it sounds like there is at least the idea of communicating through the API server is not completely bogus. It's really just a question of how often does it happen, how much communication back and forth is needed.
Yes.
There was one, I mentioned the complexity of setting up all the scheduler extenders. And there was another related question that I had. Has there been any experience in practice about performance overhead because of that when using webhooks? Because that is something that basically needs to happen each time the kube scheduler now needs information. It can't rely on anything that he has cached locally. And
well, ideally you would have these pods close to the scheduler.
Okay,
so that
is kind of the assumption is that inter-process communication is relatively fast. And
yeah,
it's right. Have people? This has been tried out then, I assume, or
I know we use it for TPUs.
Sorry, go ahead, Arlo.
Yeah, I know we use it for TPUs, but I cannot comment more than that.
Okay.
Could I ask one quick question? When you're talking about resources and allocation, you're talking about resources not including CPU and memory. What is your plan to handle that sort of scheduling where your CPUs or memory may be specific to particular types of workloads? So you have a heterogeneous cluster, for instance.
So nothing changes for CPU and memory. Those are the in-tree natively supported resources. And those will continue to be handled as they are now. That's why we basically need to coordinate between one set of resources managed and known by the kube scheduler, and then some other resources known only by some cluster add-on.
Gotcha. So there is some discussion on how to handle CPU memory resources, because part of the issue right now is kubelet assumes that they're all equivalent, right? Unless you're labeling your nodes. So that I had sent a document for CPU management use cases that includes that. It may be that these are all different pictures of the same general problem, and there may be a way we can think about it.
Yes, that's the vibe I was having when what I remember Denisio was presenting, that this could actually fall. Some of it could actually fall within the dynamic devices.
Yeah.
Yeah.
Okay.
I'm a bit wary to promise anything that goes beyond these long-lived use cases that we had in mind so far, because my expectation is what I'm currently proposing will be more complex to set up than the approach used by kube scheduler right now for the native resources. And it might not be a good fit for something that really needs to be allocated frequently and for short-lived workloads. But yeah, I guess we'll know better when we have a prototype.
Yeah. So yeah, you can start with the prototype, and if you plan to present to SIG architecture, I think that would also help. And please let us know if you do, so we can be there.
Yep. Okay.
And I don't have any other recommendations at the moment.
Thanks. Well, that helps me a bit. I guess I feel a bit more confident with just doing a prototyping now. Thanks, guys.
Yeah, it's a very interesting feature. I'm kind of looking forward for it. It's just that it's very complicated. So
Yeah,
we need to be careful.
Yeah, it's a very common problem, especially right now. Surface like topology aware plugin is also meeting some design choices. Like right now, the topology aware plugin is looking at the specific status information that the target topology provider or component provides, but that can cause latency and incorrectness for the scheduler to do good placement decision. So I think this is a general question on how to communicate this kind of information, which is needed by both the scheduler and the runtime placement component. Yeah, I think it will be a very valuable discussion if we come up with a good pattern and can generalize all the use cases.
Yes.
I think just as a thought that came to my head, we were discussing about a way that we can convey some hints from the scheduler to kubelet level as well. So that might be something we can explore as well, and that could benefit.
Yeah, that would be
these use cases.
That would be an architecture decision, actually.
Yeah.
Yeah.
Okay. Well, I hope we can discuss these kind of things in the working group batch as well. But with that, I think we're a lot out of time. So thank you all for joining today. And well, see you next time.
Yeah, thank you, everyone.
Thank you.
Thanks.
Thank you.
Bye.